So, till now we have studied the properties of the bar magnet, not only the bar magnet, just a magnetic material, and we have studied about the properties of the magnetic field lines. So, now we shall talk about how these materials, that is magnetic materials, are going to attract. It is due to the magnetic moment. What do you mean by the magnetic moment? Where these magnetic moment we are going to observe. As I told you, the material. What do you mean by the material? Material consists of the large number of atoms. Not only one, two atoms. There is a large number of atoms form a solid. That is what the material becomes. So, each atom should possesses the magnetic moment. Like this, there are several number of atoms. Each atom should possess the magnetic moment. We have to get the net magnetic moment of overall material. That we shall talk, which we call it as the atomic scale level. That means at the atomic level, how these atoms are going to behave. This is what that is what we call as the microscopic. How we can explain the microscopically the atoms. As I told you here, this is the material. These materials are made up of the large number of atoms. These are all this is a material. Inside the material, there are the large number of atoms present. Here, I talk only by considering the one atom. So, this is our atom. Okay, what atom consists of? It consists of nucleus. Around the nucleus, there is an electron. What the nucleus consists of again? Nucleus consists of proton and neutron. The combination of proton and neutron, which we call it as a nucleus. The proton has a positive charge, neutron has a neutral. Therefore, what is the net charge of the nucleus? Whether it is positive or negative. It is positive because the nucleus consists of proton and neutron. What is the charge of the proton? That is positive. What is the charge of the neutron? That is neutral. That is for zero charge. Therefore, it remains the positive. Therefore, if anybody asks what is the net charge of the nucleus, is always the positive. And what is the charge of the electron? That is negative. Due to the Coulomb force, okay, here around the nucleus there is an electron revolving. Now my question is, where the dipole moment is going to exist in the atom? That is what the magnetic moment exists in the atom I am saying. Well, now as we know, if there is a charges are flowing, it is what? The flow of charge. Consider the charges are flowing. That is what the charges are flowing in this direction. The current will develop in this direction. The direction of the flow of the charge in this, whereas the current is induced in this direction. If I use the circular coil, okay, if there is a circular coil carrying a current in this coil, it induces a magnetic moment. Okay, whenever the current flowing in this circular coil, it induces it get induced what we call the magnetic moment. Okay, so in case of this, the nucleus is not at rest, it is spinning on its own axis. Even though the nucleus isn't at the center, it is spinning on its own axis. That is what? Right. This is the nucleus, okay, which is spinning in this direction. On its own axis, it is spinning. Because of this spinning of the nucleus, there is an dipole moment exists. This is our dipole moment of this spinning nucleus. Here, now coming to the electron. Electron will revolve around the nucleus as well as the electron starts spinning on its own axis. Andre electron will ide antandre eno it spin on its own axis. Not only that, along with that it will spin. That means the electron have both momentum, that is what, the spin as well as the orbital angular momentum. Therefore, here the spinning on its own axis, how the nucleus is spinning on its own axis, in the same way the electron is also having the spinning on its own axis, as well as there is an revolving of the electron around the nucleus. Therefore, here the electron is spinning, if I say, on its own axis. So, the dipole moment in this direction. Okay, here the directions are dipole moment. This is for revolving of the electron. The dipole moment in this way, any direction. This is the electron. This is what right, spinning nucleus. This is what the spinning electron on its own axis. This is what revolving electron. In this revolving electron, the dipole moment in this direction. That means this is our atom, this is our nucleus, this is our spinning of electron, this is our revolving of the electron. So each nucleus develops a magnetic moment. Spinning electron develops a magnetic moment. Revolving electron develops a magnetic moment. The combination of all these, what will be the net magnetic moment of atom? One atom. That is, if I use this nucleus in this direction, the dipole moment of the nucleus in this direction, the dipole moment of spinning in this direction, the dipole moment of the revolving electron in this direction. Therefore, the net magnetic moment of atom is this. The net magnetic moment, if I, the resultant of these dipole magnetic moment, which gives rise to this. Therefore, if I draw, this is one of the atom, the dipole moment is in this direction. Any direction, that means the dipole magnetic moment of the spinning nucleus, the magnetic moment of the spinning electron, the magnetic moment of the revolving electron, the net magnetic moment is this. Therefore, the net resultant magnetic moment of one electron is this. In the same way, what I have explained, the individual atom can have the magnetic moment in this direction. Okay, just to observe, not only the one atom is directing the magnetic moment in this direction, the overall system is having the directional magnetic moment only in one direction. If there is an existence of the magnetic moment only in one direction of the several atoms, it is our good magnetic property. This type of material is having the magnetic property. In another case, if the atoms, the dipole moment of the individual atoms, just to observe, the dipole moment of the first atom in upward direction, the dipole moment, magnetic moment of the second atom in downward direction. If I consider the overall system of the magnetic moment, that is what the resultant magnetic moment of this material or this system is zero. What is zero? It is the resultant or net magnetic moment of this system is zero because the random directions of the magnetic moment of the individual atoms. Whereas in case of this, all the atoms is having only the one directions of the magnetic moment. Because of that, it is a good magnetic material. Whereas this is not a good magnetic material. That is, for example, hood. If I take, it is not a good magnetic material because it is not going to attract because of these phenomena which is occurring in an atomic level. That means the electron, the dipole moment, that is what the magnetic moment are random in direction. They are not in orderly arranged. They are the magnetic moments are random in direction. Individual atom have the random direction. Because of this, the net magnetic moment of this material of this system is zero. Therefore, the hood is not going to attract because of the magnetic moment of that material is zero. Whereas the iron, nickel, cobalt, all these materials are going to attract because they are having only one magnetic moment of the atom having the same. That means the atoms arranged orderly, not only orderly, even though the magnetic moment are also in the same direction. Because of this, there is a good magnetic property. If I talk, what will be the spinning of the electron? What will be the spinning of the nucleus and revolving of the electron? Mathematically, if I draw right, shall I write this? So, mathematically, magnetic moment due to revolving electron is given by minus E at next the magnetic moment due to spinning electron in the same way the magnetic moment due to spinning nucleus is, this is what we know Okay. Mathematically, if I mention the magnetic moment due to the revolving electron is given by minus E times HL divided by 4 pi mc. This is the magnetic moment of the revolving electron. Here E is the charge of the electron, H is the Planck's constant, L is the orbital quantum number. What it tells? It tells us about the shape of the orbit and also the size of the orbit. And 4 pi mc, m is our mass of the electron and c is the speed of light. In the same way, the magnetic moment due to the spinning electron, as I told you, if the electron is in, it is spin on its own, not only the revolving, even though it spins. In that case, the formula we write for the magnetic moment of the spinning electron, that is EH divided by 4 pi mc. Here, just the orbital quantum number is going to skip. Whereas the magnetic moment due to the spinning nucleus, that means the nucleus is also spinning on its own axis. Therefore, I can write the formula that is EH divided by 4 pi mpc. That is what the mass of proton. Here C refers for the speed of light. Okay, this is about the atomic level of the magnetism. That means inside the atom there is an existence of the spinning of electron, revolving of electron, spinning of the nucleus. The net magnetic moment of one atom is this. Therefore, this system having the magnetic material. Whereas this system we can make as a magnetic material by inducing some of the external magnetic field. That means this material, if I keep under the external magnetic field, in that case what happens? It starts aligning only in one direction. That means whatever the random directions of the magnetic moment was there, in that case automatically it starts all the magnetic moment in one direction. That means even though the non-magnetic material, we can make it as a material by inducing an external magnetic field to the given material. So this is what about the atomic level. This you should understand. Now, coming to the next point, that is what? Earth also behaves as a magnet. Okay? Earth also behaves as a magnet. We are saying that Earth is also behaving as a magnet. So if I draw, this is our Earth. Just assume there is a magnetic compass placed in the center of the Earth. Just I draw magnetic. This is our Earth, and we have placed the magnetic compass at the center of the Earth. In that case, this is our north geographic, this is our south geographic. This axis, which we call it as the geographical axis, this is our geographical axis of the Earth. Whereas this axis is the magnetic axis. This is our magnetic axis. Just remember the magnetic axis and the Earth, that is what the geographic axis can never intersect. They are made by a certain angle, that is what up to the 15 degrees to angle difference ಇರ್ತದೆ. ಯಾವ್ಯಾವುದಕ್ಕೆ? This is our geographic axis, this is our magnetic axis. This is our geographic north, this is our geographic south of the Earth. We have placed a magnet at the center of the Earth. That means what pole should occur in this? It should have the south. That is what the magnetic south pole, whereas this is our magnetic north pole. Then only it starts attracting. As I told you, if I write the north, it starts repelling. But it does not repel, it starts deflecting or aligning towards the north itself because of Earth behaves as a magnet. Okay? Therefore, the magnetic compass, which is having the south near to the north, geographic north, and the magnetic north should have the geographic south, and can geographic axis, magnetic axis cannot intersect each other. It is by making an angle 15 degree each. Angle about 15 degrees to difference into the geographic axis get magnetic axis. This is our geographic axis. This is our magnetic axis of the bar magnet, geographic axis of the Earth. So, as I told you, the Earth behaves as a magnet due to this. That is what I told you, stars in this direction, north to south. Here, south to north stars. They are north in the south. Okay, so this is how the Earth behaves as a magnet. Therefore, Earth itself having the magnetic field. Sir, you are saying Earth is a magnet having the magnetic field. If Earth has a magnetic field, it would have attracted all the